So let me just do a quick introduction. I run the global DevOps practice at Splunk, and I also run our practitioner team, so I get to be a manager and an individual contributor, so it's always fun kind of going back and forth. But one of the things that Splunk really fosters is, if you have an ideal and you want to foster a program out of it, you can build an incubation out of it. So DevSecOps is actually one of my incubations, and I'm really excited because this is something I've been doing over the last 15 years. So a couple of my coworkers know what I've done in the past. I won't get too descriptive into it, but it's an environment that is very hackable and highly desirable to hack into. And so a lot of the concepts that I'm going to present today are stuff I've learned over the years, through breaches, through being up 96 hours to basically remediate an attack, denial of service attacks, and everything else. And these are the concepts that I look at when I actually design new applications. And that's really kind of a passion of mine. So a couple things we're going to go off today is we're going to look at the hazards. When we think about DevSecOps, there's a lot of different things that teams may or may not know about how their applications are built or even how they're deployed. Different types of approaches when you're talking with your team around the collaboration, communication, and documentation stages. Technical best practices, and then also privacy best practices, because we want to make sure that we're compliant with government regulatories and also understanding how people are interacting with the data that they're getting so they can make better decisions. And then I'm just doing a quick Q&A. Typically this is like a 40-minute presentation, but I'm going to get it done in 20 minutes. All right, so really exciting. As you guys are aware, we're dealing with very highly complex environments. I work with a lot of teams that either say their environment's convoluted and they don't even understand how it works, or we have teams that actually have it very well documented and they try to simplify the process. And so when I think about the majority of customers, they're kind of in the space where they're modernizing their applications and their environments, and they're also taking an overly complex DevOps process and trying to simplify it so that all the teams understand how things work. It's something we're doing at Splunk today. I remember it used to take us 40 hours to troubleshoot bugs. Now we're down to less than about 3 hours. So really cool concept when you think about taking a look at that. So the first thing, modernization of environments. So how many of you guys are working in kind of a split silo team in your organization today? Well, pretty good number. So one of the things that I always kind of talk to people about, and this is something that's really important, is there's a lot of silos where teams just don't want to talk to each other. It's more about finger pointing, and it's more about putting the blame game than actually trying to remediate the issues. And so in a lot of cases, you may have a dev team that potentially may talk to the security team if they feel like it, and then when something fails or there's a hack going on, the dev team's like, okay, I'm throwing over the fence, and I'm going to let operations and security deal with it. And so those are kind of the things that we're trying to remediate when we talk about DevSecOps, because we want to build this collaboration between these groups. As you can tell, it's a very process-defined environment. Developers care about one thing, operations cares about one thing, but security cares about everything. So how do we get the communication between the teams that come together and helping them understand why it's important to document and communicate process and actually getting things kind of in sync. And ultimately security is the gatekeeper to a lot of stuff, and I always kind of tell developers, hey, if you want money, talk to your security team. They'll give it to you. You just got to give them a purpose to do it. So second thing is taking these overly complex DevOps practices. How many of you guys are going through a transformation right now? How painful is it? Very painful, right? So one of the things that we need to do, kind of as practitioners, as subject matter expertise within the DevOps tool stack, is really kind of understanding where my vulnerabilities or things that may happen in my environment. How do those impact how the security of my application goes out when a customer interacts with it, or even our internal customers? So the ideal is, security is not a winning formula. Let's go ahead and find out what needs to be protected, why it needs to be protected, and how to provide protection so that we don't have to have the security team hunting for things. What's really important with a lot of hunters is if you don't have documentation on the application works, or if you don't have proper logging standards, they're going to spend hours trying to figure out what your code's doing, and then when they're trying to remediate a vulnerability, they're cussing your name out because they really can't figure it out, and they're having to ask a million questions, wake people up. By basically going this route of being very prescriptive and asking the right questions, you can actually get a security team really happy when they're hunting for a specific vulnerability. They can actually find what is causing the problem and actually communicate with the developers really quickly to fix it. Because the security team is really not responsible for going into someone's code and fixing it. They need to find out why the vulnerability is there, remediate it, and then pass it along to the next team. And it always comes down to financial impact. I mean, you think about all the breaches that we've had, over the last couple of years. I mean, just in 2017, we had 1,579 breaches. I mean, think about all the customer data that we have out there currently today are just very simple mistakes like, unencrypted passwords or APIs that are open. Think about, the dark web where everyone can buy, your password information for pennies on the dollar. Why do we actually have an environment like that? It's because sometimes we don't plan for those specific end results. And when we have to do root cause analysis on it, it's very expensive. You have to have compliance officers come in, you have outside consultants. Why go through that effort when you can actually just fix it when you're building an application? Okay, so first best practice, having a single source of truth. How many of you guys are currently using some type of documentation or collaboration suite? Okay, well, I'm kind of surprised not everyone's doing it. The important thing about this is really kind of having a central repository of what's being changed in the environment, what the environment looks like, but then also what revisions and new features are being added every day. So this is a concept that I've been working with a lot of customers on. We take the whole concept of the technical theory of how DevOps platforms should work, and we actually align it to the business workflow action. So the ideal is, with the way that we have our tool sets, how they communicate each other, how do they interact with each other, and how does it relate to business operations? So in a planning process, how does the PMs and developers work together? How do they design the backlogs? Are those checks in place to determine if there's a developer taking on more work they need? Or is there someone that's making changes within the code that's not actually being documented? So when you think about all the different types of theories within like the build pipeline, and then also aligning it to how business runs, there's a lot of disconnects within these different groups. So the concept is really simplify what you're doing, building a repeatable and learnable process. So if you fail at something, don't just give up on it. Try to reiterate based on it, document it, and actually talk about your failure points. I think that's the biggest thing in the practice right now is people just are afraid to say that they failed at something, and they don't document it. And then the next person that comes in, that tribal knowledge is gone, and then they have to fail again. So the company's constantly losing money because they don't have that ability to remember that we've already gone down this path. Why do we have to keep repeating it? And the same concept goes for release and deploy. I mean, with a lot of teams having separate deployment teams that basically just take binaries and artifacts and ship it into their production environments, sometimes they need a little bit more context around what they're deploying. So why did a package go from 10 megabytes to 35 megabytes? How many other packages are we deploying in this environment? Is this a normal progression of how this package is being deployed? A really good use case, and this is something that is painful for the company to go through, but they actually had an attack, and it hit the news in EMEA, where this developer, who's a contractor, actually exfiltrated this banking system, put a blockchain encryption within the code base, got an airplane, activated the timer, and encrypted their whole database for 24 hours, and no one could get their money out of the banks. So a contractor who bypassed a very undocumented system was able to put code in and then deploy the code and then get off, basically fly back to Russia, and he's gone now. Those are kind of the things when you think about having that repeatable and learnable process of documenting things. That's really what kind of changes the game when you know that if someone's circumventing the system, you can get alerting or you can get some type of notification that says that something's going on. And unfortunately with that client, it took them a really hard time to basically understand how that hacker got into it. It took them 2 years to figure it out. And by that time, it was too late. All that artifact, all that information was already aged out, and they had to reassemble it piece by piece. Second thing is security by design. So there's a lot of different things that we have to take a look at. As you're moving from an ITIL process to an agile process, there's a lot of similarities that you can kind of take security into that principle. So, looking at how you do change management, how you actually put audit controls within your system. I actually worked for a company locally in the Valley who actually had a very open system that we were working on government contracts, building private cloud solutions. We had no auditing in place. And so that was part of the contract requirements. When you communicate that to the team, people actually really think about, this is a government institution, we want them to be secure, we got to build it into our practice. And sometimes it's just reminding people that we need to do it. And then also having the response framework. So regardless if it's automated or manual, is there a way for you to actually respond to alerts or notifications that are coming in? And the way that we do that is basically looking at what's normal. So we identify the services and actual interactions between different services. We record what's normal. We analyze it. review it, and then we also monitor it. So it's kind of that repetitive process of taking a look at what's normal in my environment from baseline, looking at anomalies, making adjustments based on that, and then documenting what you have based on the code releases that you're doing. And a great example is, let's say for you're running a banking application, and you're basically providing some type of capture, so when a person goes up to an ATM, it takes a picture to verify that you're truly that person using AI ops. The ideal is when you have the response framework, you can actually build it into your product set to not only notify the developers that this feature is working, but also let the business know how often it's being used and basically the risk mitigation associated. How much money did I save by implementing this feature, and being able to communicate it back and forth. And so documenting how we actually do security is the biggest thing. And I've seen this practice, as long as you keep it simplistic, you'll be able to repeat it over and over again and iterate based on it. The security lifecycle is really important. It's very similar to the dev lifecycle. The only difference is we're really looking at how do we communicate, different regulatory requirements and overlaying them on developers, productivity, helping them understand why they need to do certain types of features and requests, and then also taking a kind of risk mitigation approach to say, okay, we're working with a critical environment. These things have to be encrypted. These are documented methods on how we do it. Everyone's aware of the situation, and we design it, we deploy it, we implement it, and we learn from that from each exercise, so that when you're building testing frameworks in your code before you even put it into production, all these are being taken into account for, and security is going to know that you've already taken the precautions to do it. So when a breach happens, you actually have an ability to take a look at what's normal behavior. And then when you try to look for anomalous behavior, you can see the deviation and patterns. And what's great is as we get into machine learning, unsupervised and supervised, we have an ability to basically build models based on what is normal, what's abnormal, and detect things before they even happen. So it's all about predictability, okay? And that's the third concept, security is predictable. This is one of the things that a lot of companies have a hard time with. They think that security is kind of like a chaotic machine, and that we have to install firewalls, endpoints, all these different things. When you take the precaution to basically instrument, all the different functionality of your code, even if it's a COTS platform, taking a look at how these things interact with different services, you can see what and how what people are doing in your application, so that you can actually see what's normal. And so this is another concept that we created really around identifying, like, how do we automate things very quickly, and how do we automate them very often. A lot of financial customers I've been working with, this is a very clear concept. It's really about helping them understand what they're building, how they automate some of the remedial things, and then ultimately how do we monitor it so that if something does happen, we can predictively figure out if it's going to fail, or it's something that we should look at right away if it's anomalous behavior. And I think it's really important when you think about the concept of DevSecOps, because this requires full team collaboration. You just can't have an operations team or dev team saying that, oh, I think something's wrong, and just throw it over to security. All these teams have to work together and follow the same process, okay? And then the third is understanding your environment. How many of you guys understand your environment from top to bottom? There you go. It's really hard, especially when you're working in a large corporation, having multiple data centers. At one point in my career, we had about 7 data centers. I had about 30 private cloud solutions that were running. And it was painful because every time we iterated on a new project, we would run out of time to document what we did, and then we'd have to work on the next revision and the next customer. And this is something that I wish I would have had when I first started doing some of the private cloud solutions, because I really didn't think about, what are the potential threats could happen if this is a publicly available cloud product. And one of the things that I think people do when they build applications are just like, okay, feature functionalities, let's just get it out into the wild. And you don't think about the threats associated with it. Things I've learned throughout my career is developers can be very lazy. They don't like sanitizing anything that's coming into the system through user inputs. People who actually have to do operations and development, they're really kind of just like, okay, I'm just going to throw up an environment, no firewall, no ACL rules, just get everything done and ready to go. But basically using this model, we can actually say, hey, if I was an outside hacker, what would I do to this system and how could I get in? And taking that concept, you can work backwards and say, okay, if I want to basically protect it so that no one can just log in the system randomly, I should have a firewall that blocks all rules except for an IP block. And then going back and saying, if I don't have this, what would be the impact to this application? And if I know the impact, I know exactly what resources and threats that I need to basically mitigate against and vulnerabilities that I need to look at so that it's a repeatable process that I'm learning from it, okay? And just to kind of summarize, this is something I normally do in 40 minutes, but these are the 4 concepts, single source of truth, security by design, security has predictability, and then understanding your environment. And I'm going to leave that up for questions if anyone has any.
Right before you do questions, I wanted to share, I just found this article that Bloomberg just posted stating that a company called UpGuard has identified 100,000 open databases that are available to access on Amazon systems.
Yep.
And that the second largest amount of data that they continue to find were information collected from Facebook.
Yep.
User information that's been just openly available on Amazon. That's just creepy.
And that goes to the same concept. Developers are going to want to do what they need to do to get their job done. They don't really think about anything besides that. We do a lot of customers, they're on either very shoestring budgets or they're trying to basically build a team, and they just don't have the experience to think about this stuff. And so a lot of these practices are very simplistic in nature. It's just telling people, think about, how you would make a cake. You have to have the ingredients in place. You have to know the measurements. It's the exact same thing with security. I need to know my threats that are outside. I need to make assumptions that this may happen, and I need preventions to basically make sure it doesn't happen to me. And like I said, 1,500 breaches in 2017. I'm sure 18 and 19 are going to be pretty stellar as well. So, cool.
Yeah. So with DevSecOps and the amalgamation of everything, what are your thoughts on separation and segregation of duties and how it plays into DevSecOps?
So the way that I look at DevSecOps, segregating duties is probably is a really bad thing. And the reason why I'm saying that is if you're not communicating with other teams on how you're doing deployments or how you're writing code, when something happens, and let's say, for example, your main developer who has built your majority of your application leaves, that tribal knowledge goes away, and there's no one else to take over. And so basically like having stand-ups with what I call stakeholders in each one of these groups so they understand how something works makes it possible for people to expand their knowledge, take interest in what's happening, and then ultimately the collaboration goal is not to be woken up at 2 in the morning because there's a breach going on that everyone has to get in a war room and deal with it. So,
thank you very much, Dom.